What if the US bioweapon programs that have killed thousands of people in the past are still ongoing? The US worked on many bioweapon programs, and the worst part is that most of these weapons were made in Africa. The US used Africa to manufacture these weapons, which, in turn, caused Africa to suffer the most. However, some experts are saying that the programs that were supposedly ended decades ago are, in fact, still active in Africa. But is that true, and what weapons is the US currently manufacturing? Let's find out. Recent claims and reports suggest that the United States has transferred some biological research projects to various African countries, including Cameroon, the Democratic Republic of the Congo, Nigeria, Sierra Leone, and Uganda. These assertions, primarily put forth by Russian officials, allege that the US relocated some of its unfinished projects related to biological weapons research to these African nations. The implications of such allegations have sparked concerns regarding the nature and objectives of these purported projects, particularly in light of stated goals, such as combating HIV/AIDS and supporting public health initiatives. The allegations made by Russian officials imply a significant transfer of sensitive biological research activities from one region to another. Specifically, the claim suggests relocating projects previously underway in Ukraine to several African countries. The choice of African countries as locations for these alleged projects raises additional questions. Historically, African nations have faced challenges in health infrastructure, governance, and socio-economic development. Introducing sensitive biological research activities in these contexts requires careful consideration of the potential risks and benefits, as well as the capacity of local institutions to oversee and manage such actions effectively. We have covered a video on how bioweapons are made in Africa. Today, we will discuss some programs that are said to have already ended but are still ongoing. According to some experts, these weapons are being made in Africa to this day and were thought to have ended decades ago. Firstly, we have Bacillus anthracis anthrax. Anthrax caused by the bacterium. Bacillus anthracis stands as a grim example of the devastating potential of biological weapons. While primarily known as a disease affecting livestock, anthrax gained infamy as a potent tool of warfare during the 20th century. Among the various bioagents, anthrax was prominently weaponized, notably during the United States biological weapons program. Bacillus anthracis is found naturally in soils and can infect animals by ingesting or inhaling its spores. When used as a weapon, anthrax spores are typically dispersed in aerosol form, allowing them to be inhaled by unsuspecting victims. Once inhaled, the spores can germinate within the body, releasing deadly toxins that wreak havoc on the respiratory system and other organs. During the mid-20th century, the United States initiated a classified biological weapons program, commonly known as the U.S. Offensive Biological Warfare Program. Anthrax was among the pathogens weaponized by this program, which aimed to develop and stockpile biological agents for potential use in warfare. The program conducted extensive research into methods of producing large quantities of anthrax spores and refining techniques for dispersal. One of the most notorious incidents involving anthrax as a bioweapon occurred in 2001, when letters containing powdered anthrax spores were mailed to several media outlets and government offices in the United States. The ensuing anthrax attacks resulted in 22 cases of anthrax infection, including 5 fatalities. The incident highlighted the vulnerability of modern societies to biological threats and underscored the need for robust preparedness and response measures. In addition to its use as a weapon of bioterrorism, anthrax remains a concern for biodefense and public health efforts. Efforts to develop vaccines and treatments against anthrax continue, aimed at mitigating the impact of potential future outbreaks or deliberate attacks. The legacy of anthrax as a bioweapon serves as a stark reminder of the dual-use nature of biological research and the ethical considerations surrounding its development and deployment. While advancements in biotechnology hold promise for improving human health and well-being, they also raise concerns about the misuse of biological agents for destructive purposes. Vigilance, international cooperation, and adherence to ethical norms are essential in preventing the proliferation and misuse of bioweapons like anthrax, ensuring that humanity can harness the benefits of biotechnology while averting its darker implications. Then there is Francisella tularensis tularemia. Francisella tularensis, the bacterium responsible for tularemia, emerges as a natural menace and a weapon of choice in biological warfare. This highly infectious disease, characterized by fever, skin ulcers, and swollen lymph nodes, has been harnessed as a bioagent, notably during the covert operations of the U.S. Biological Weapons Program. Here's a reminder to please like and share the video and subscribe to our channel to watch more videos on Black culture, history, civilization, and identity. Let's continue now. Tularemia, often called rabbit fever, due to its prevalence in wild rabbits and rodents, is endemic to various regions worldwide. Humans can contract the disease by contacting infected animals, ingesting contaminated water or food, or inhaling aerosolized bacteria. While tularemia is relatively rare compared to other infectious diseases, its potential as a biological weapon lies in its high infectivity and the severity of illness it can cause. During the Cold War era, the United States pursued an ambitious biological weapons program aiming to develop and stockpile a diverse array of biological agents for potential use in warfare. Among these agents was Francisella tularensis, which garnered attention for its ability to incapacitate and kill enemy forces while leaving infrastructure intact. Research conducted under the auspices of the U.S. Biological Weapons Program focused on weaponizing tularemia, seeking to optimize methods of production, stabilization, and delivery. Aerosolization emerged as a favored method for dispersing tularemia, allowing for the widespread dissemination of the bacterium over large areas, maximizing its potential impact on targeted populations. While tularemia has historically been associated with natural outbreaks and sporadic cases, instances of its use as a weapon of bioterrorism or biological warfare have been rare. However, the potential for deliberate dissemination of tularemia by state or non-state actors remains a concern for biodefense experts and public health officials. Efforts to combat tularemia, whether natural or man-made, rely on surveillance, early detection, and rapid response measures. Vaccines and antibiotics are available for the prevention and treatment of tularemia. Still, their efficacy may be limited in a large-scale outbreak or deliberate bacterium release. Some experts say this weapon is still made, and it is made by the U.S., probably in Africa. Then there is botulinum toxin. Botulinum toxin, produced by the bacterium Clostridium botulinum, is one of the most potent neurotoxins known to humanity. While renowned for its medical applications in cosmetic treatments and muscle disorders, this toxin has a sinister side. It has been weaponized by the United States for potential use as a biological weapon. Clostridium botulinum, commonly found in soil and marine sediments, produces botulinum toxin under anaerobic conditions. The toxin exists in multiple forms, with serotypes A, B, E, and F being the most clinically significant. Botulinum toxin inhibits the release of acetylcholine, a neurotransmitter responsible for muscle contraction. If left untreated, this can lead to muscle paralysis, respiratory failure, and potentially death. During the 20th century, the United States explored the weaponization of botulinum toxin as part of its biological weapons program. This program aimed to develop a diverse arsenal of biological agents for potential use in warfare. Botulinum toxin's extreme potency and ability to cause widespread paralysis made it an attractive candidate for military applications. The potential use of botulinum toxin as a biological weapon raises significant concerns due to its high lethality and ease of dissemination. In aerosolized form, the toxin could be dispersed over a wide area, affecting large populations with minimal effort. Furthermore, the absence of a readily available antidote complicates efforts to mitigate the effects of botulinum toxin exposure in the event of an attack. Despite its potential as a weapon of mass destruction, botulinum toxin also plays a crucial role in medical therapeutics. In controlled doses, it is used to treat various medical conditions, including muscle spasms, migraines, and excessive sweating. The dual-use nature of botulinum toxin underscores the ethical complexities surrounding its research and regulation. Efforts to counter the threat posed by botulinum toxin include the development of vaccines and antitoxins, as well as surveillance systems to detect and respond to potential outbreaks or deliberate releases. International cooperation and adherence to biological weapons conventions are also essential in preventing the proliferation and misuse of botulinum toxin and other bioagents. Then we have Brucella spp, the causative agent of brucellosis, is a group of bacteria threatening human and animal health. While primarily known for causing debilitating infections in livestock such as cattle, goats, and sheep, Brucella spp has also been weaponized, notably by the United States in its biological weapons program. Brucellosis, or undulant or Malta fever in humans, is typically transmitted through contaminated dairy products or direct contact with infected animals or bodily fluids. The disease manifests with symptoms including fever, fatigue, joint pain, and severe complications affecting the heart, liver, or central nervous system. In biological warfare, Brucella spp presents a unique challenge due to its ability to infect animals and humans, potentially disrupting food supplies and causing widespread illness. The United States Biological Weapons Program explored the weaponization of Brucella spp as part of its efforts to develop a diverse array of biological agents for potential use in warfare. The inclusion of Brucella spp in the U.S. Biological Weapons Program highlights the perceived strategic value of this pathogen in military contexts. Deliberate dissemination of Brucella spp could result in significant economic losses in agricultural sectors and widespread illness and societal disruption in affected populations. Efforts to counter the threat posed by Brucella spp include surveillance and monitoring of livestock populations and the development of vaccines for both animal and human use. Vaccination programs aimed at reducing the prevalence of brucellosis in livestock have been implemented in many countries, helping to mitigate the risk of zoonotic transmission to humans. However, Brucella spp's potential dual-use nature highlights the ethical complexities surrounding its research and regulation. While efforts to develop vaccines and treatments for brucellosis are crucial for public health preparedness, stringent controls are necessary to prevent the misuse of these agents for nefarious purposes. Then comes Coxiella burnetii Q fever. Coxiella burnetii, the bacterium responsible for Q fever, emerges as a stealthy adversary capable of inciting widespread illness and societal disruption. While initially recognized for its impact on animal health, particularly in livestock, Coxiella burnetii has been identified as a potential bioagent, included in the United States Biological Weapons Program. Q fever, named for query fever, due to its initial mystery of origin, manifests as a flu-like illness in humans, often accompanied by fever, chills, headache, and muscle pain. Severe cases may lead to pneumonia, hepatitis, or endocarditis, posing significant health risks to affected individuals. Transmission typically occurs by inhaling contaminated aerosols from infected animals or their environments. The inclusion of Coxiella burnetii in the U.S. Biological Weapons Program underscores the perceived strategic value of this pathogen in military contexts. Deliberate dissemination of Q fever could result in significant societal disruption and economic losses, particularly in agricultural settings where livestock are susceptible to infection. Furthermore, the ability of Coxiella burnetii to form highly resistant spores enables its survival in various environmental conditions, facilitating its potential use as a bioagent. Aerosolized spores could be dispersed over wide areas, infecting humans and animals and amplifying the impact of an intentional release. Efforts to counter the threat posed by Coxiella burnetii include a surveillance and monitoring of livestock populations and the development of vaccines for both animal and human use. Vaccination programs aimed at reducing the prevalence of Q fever in livestock have been implemented in many countries, helping to mitigate the risk of transmission to humans. Then comes the Venezuelan equine encephalitis virus. The Venezuelan equine encephalitis virus, VEV, is a menacing pathogen capable of causing severe neurological disease in both horses and humans. Its potential as a biological weapon has long been recognized, with the United States conducting research into its weaponization as part of its biological weapons program. VEV belongs to the family Togaviridae and is transmitted primarily by mosquitoes. In horses, the virus can lead to symptoms ranging from fever and lethargy to neurological manifestations such as ataxia, tremors, and paralysis. In humans, VIV infection can result in a spectrum of illnesses, from mild flu-like symptoms to severe neurological complications, including encephalitis, which can be fatal. The inclusion of VIV in the U.S. biological weapons program highlights its potential as a tool of biological warfare. The virus's ability to cause widespread illness and incapacitation in animals and humans made it an attractive candidate for military applications. Furthermore, its natural transmission cycle involving mosquitoes provides a means of covert dissemination over large geographic areas. Research into the weaponization of VIV aimed to enhance the virus's stability, virulence, and means of delivery to maximize its effectiveness as a biological weapon. Aerosolization of the virus for dispersal over target populations was among the strategies explored, highlighting the potential for VIV to be deployed in acts of bioterrorism or biological warfare. Efforts to counter the threat posed by VIV include surveillance and monitoring mosquito populations in endemic regions and developing vaccines and antiviral therapies. Vaccination of at-risk populations, such as laboratory workers and military personnel, is crucial for mitigating the risk of VIV infection in the event of deliberate release. Then there is staphylococcal enterotoxin B. Staphylococcal enterotoxin B, SEB, a potent toxin produced by the bacterium Staphylococcus aureus, has earned notoriety for its ability to cause severe food poisoning and toxic shock syndrome. However, its inclusion in the United States biological weapons program sheds light on its potential as a sinister tool of biological warfare. SEB is classified as a superantigen, an antigen that triggers an exaggerated immune response, leading to systemic effects such as fever, vomiting, diarrhea, and, in severe cases, shock and organ failure. The bacterium responsible for producing SEB, Staphylococcus aureus, is commonly found on humans and animals' skin and mucous membranes, making it ubiquitous in the environment. The United States' interest in SEB as a biological weapon stemmed from its ability to cause widespread illness and incapacitation when aerosolized and dispersed over populated areas. Unlike traditional pathogens, SEB does not replicate within the host's body, but rather exerts its toxic effects upon exposure, making it an attractive option for covert dissemination in acts of bioterrorism or biological warfare. The weaponization of SEB involved efforts to enhance its stability, potency, and means of delivery to maximize its effectiveness as a biological weapon. Aerosolizing SEB for dispersal over target populations was among the strategies explored, highlighting the potential for SEB to inflict mass casualties and sow panic and chaos. Efforts to counter the threat posed by SEB include the development of vaccines and therapeutics, targeting the toxin's effects and surveillance systems to detect and respond to potential outbreaks or deliberate releases. Vaccination of at-risk populations and first responders is crucial for mitigating the impact of SEB exposure and preventing its widespread dissemination. While the United States officially declared the cessation of its biological weapons program and the destruction of its stockpiles by international treaties, some experts raise doubts about the complete cessation of such activities. They suggest that the U.S. might still be engaging in covert research and development of biological weapons, potentially leveraging African countries as sites for these activities. The question then arises, why Africa? Various foreign powers have historically exploited the continent for its abundant natural resources and minerals. However, allegations of hosting covert biological weapon projects add another dimension to Africa's troubled relationship with foreign powers. Critics argue that the United States, among others, has a history of exploiting African nations for its geopolitical and strategic interests, often at the expense of local populations' well-being and sovereignty. The alleged involvement of African countries in hosting potentially harmful biological research projects has prompted significant backlash and calls for accountability. African nations, mindful of their sovereignty and the welfare of their citizens, have expressed unease over being used as sites for such controversial activities. The perceived exploitation of Africa for nefarious purposes further strains diplomatic relations and fuels distrust toward foreign powers, including the United States. Consequently, there has been growing sentiment within Africa advocating for the termination of ties with the United States and other foreign entities engaged in activities perceived as detrimental to the continent's interests. calls for greater transparency, accountability, and respect for national sovereignty echo across the continent as African nations seek to assert control over their destinies and safeguard against external manipulation. How will Africa stop the US from using Africa for bioweapons? African countries must engage in diplomatic discussions with the United States and other relevant stakeholders to express their concerns regarding the alleged use of Africa for bioweapons research. Through diplomatic channels, they can seek assurances and commitments from foreign governments to respect their sovereignty and refrain from engaging in activities that could jeopardize public health and security. African nations must collaborate with international organizations, such as the United Nations and the World Health Organization, to raise awareness about the issue of bioweapons proliferation and advocate for stronger regulations and oversight mechanisms. By engaging in multilateral efforts, African countries can amplify their voices and exert pressure on the international community to address the root causes of the problem. African governments should also enact legislation and regulatory frameworks to strengthen oversight of research activities within their borders, including those related to biotechnology and bioweapons. Implementing robust legal mechanisms can enhance transparency, accountability, and compliance with international norms and standards. African countries can also invest in building their scientific and technical capabilities to independently monitor and assess research activities that could pose risks to public health and security. By developing indigenous expertise and infrastructure, they can reduce reliance on external actors and assert greater control over research conducted within their territories. Civil society organizations and grassroots movements also play a critical role in advocating for transparency and accountability in research activities related to bioweapons. By mobilizing public opinion and holding governments accountable, civil society can pressure decision-makers to prioritize protecting public health and safety. Do you think Africa should allow these weapons to be made? How do you think it can be stopped? In the comment section, let us know what would happen if the US never stopped. Do you want to watch more videos like this one? If so, subscribe to our channel and press the bell icon next to it. We have decided to bring videos on something nobody talks about: the Black culture, civilization, history, and evidence about how glorious Blacks have been. Thanks for watching, and until the next video, stay tuned.